Welcome to our workshop on high performance computing. My name is Guillermo-Franco, and on this video we will talk about the command line interface. When you are interacting with an HPC cluster, you usually do that through a terminal interface. The reason for that is that an HPC cluster is usually shared infrastructure, so in general, many people is accessing this machine on real time. So the best way for interacting with this machine has been for a long time using a terminal interface. With a terminal interface, you have basically a screen with one small message and waiting for you to start typing commands to the machine. You type your command, you hit enter, and you get an answer, you get a result out of that, and the process continue. So this very streamlined way of interacting with computer is extremely powerful and allow you to do things on a scale that is basically not possible if your interaction is in real time and you have to start clicking buttons here and there, or moving your mouse, or waiting for you to execute actions as you typically do on your desktop computer. So the first thing that we need to know is that for start learning or start interacting with an HPC cluster, you need to learn Linux commands. That's the first thing. On this figure right now that you see on the screen, there is like a spiral of commands, more or less compacted in topically, several of them. This is not and by far an exhaustive collection of Linux commands. This is just the tip of the iceberg, if you want, and even this is too much, so for beginners at least. So what I have decided is to select just 10 commands that we will be learning and that will give you some first experience and some the ability to start performing actions of on the cluster. So let's move to the demonstration, what we will be doing. So right now I am on Thorny Flat. It will be pretty much the same if you are working or if your account was on a Spruce. What we will be doing is basically equivalent on any cluster that you are dealing with. So the first command, let's start with this. Echo is basically a way of printing messages on the screen. So you type echo and you type the message that you want, and the result is aligned with that message, and you return back to your prompt. This line that you see here in colors that I have personalized for me for my activity is called the prompt. So when I see this, it's an indication that the system is waiting for me to type a comment. So I just type the first one. Let's see another command that is often used on HPC jobs is this. You want to know, for example, when something starts, or you just would like to execute this command, date. And they have a predefined format for writing the date. You can change that. We will see that later. But this is basically the command for that. So now, and a small trick here, now that we have typed a couple of commands, is that you can use your arrow keys on your keyboard, and you can see on the right side that I have a small application that is showing the commands, that everything that I'm typing on the computer. So I can type the up arrow here, and you will see the command that I execute before, and I type again, and I see the command that I execute before that. So if I hit enter, you see the same result, but there is a small variation here. We would like to direct this into a file. So this is a way of redirecting the output that normally will be shown on your screen, be redirected into a text file. So I will be doing this to let's say welcome, and I can put an extension. Extensions on Linux, Unix doesn't have the same relevance as they have on Windows, but probably it could be good to have that kind of extensions for us to know what that file contains. So you see now that I have not message shown on my screen, but the content of that file was redirected towards a file. And I can do something like that this way. And also I can type, I just type welk, and I can use the tabulator on your keyboard to complete the name of the file. So the system will search if there is a unique way of completing this file, and just hitting tab will complete that. So using the arrow keys and the tab is very handy when you are working on a terminal. And if I do this, I will be overwriting the welcome.txt file. If I don't want to do that, but just appending the content of the date into the same file, in that case I will be using a double bigger than, and the output of the command date will be redirected to the end of the text file on welcome.txt. So now the next command that is important for us to know is cat command to see the content of a file. So I hit tab again, it's complete the name of the file, and can see the content of that file. Notice that we have hello, that we redirect that and when we create this file, and the date that we append to the file after that. Okay, and this is our first set of commands. So now on Unix machine, Linux in particular, but in general in Unix, files are organized in a tree. It's similar to what you can see on a Windows machine or Mac OS. The difference comes in the case of Windows when you have those drives, C drive, B drive. This is very particular for Windows. Mac OS that uses a Unix distribution or has a legacy from a Unix distribution works very similar to Linux in this regard. So they organize all the files in the system in a hierarchy that starts with this. So the next thing that we will be doing is to change directories. So we will explore this a little bit and using it. So with cd, we will be changing to the directory you want. Let's start with this. This is the root folder. So this is the lowest or highest, it depends how you look at it, folder that you can think on a Unix machine. This is the first folder, or directory, as it's called. So cd stands for change directory, and here we can see the folders that we have on this machine. Many of them are very standard on Linux systems, on Unix or Linux systems. And this is something that you can see. You can start going into the different folders if you have permissions for looking into those folders. And we have for this particular folder. So let's go into my folder. So before that, let's execute this command to know where we are. So we are right now, show me my working directory, print my working directory, and it will tell you, okay, you are in the root folder. I can go to my own folder like this, or if I am here, another way of doing exactly the same is just hit cd and it will redirect to my home folder, and I can execute pwd to see my current location, and effectively I am on my own folder. So now the next thing that we can do is start creating folders or directories. If you are working in several projects or different simulations, for example, under different conditions, or for different specimens, so you maybe would like to organize those different entities into folders and subfolders in such a way that they have a structure that makes sense to you. So let's start with this. Let's imagine that I would like to create something like a project folder. So I can use this command to create directories. Make a directory. Project 2020. I create a directory with that name. You can create directories with the spaces, but dealing with the spaces on the command on the terminal is not very comfortable. So try to avoid that if you can. But if you want to make a space, you have basically two options. You can put everything in double quotes, and you create that folder, or you can start escaping those escape spaces. If you don't want to use this, you have to use something like this. Okay, so let's go into one of those folders that I just created here, and I can create subfolders. So let's see where we are right now. So we are here in users Franco project 2020, and I would like to create, let's say, three subfolders at this point for 3 samples. Imagine that I have samples, so I can create sample 1, sample 2, sample 3. Now we can use exactly the same command that we used when we were in the root folder to see what we have right now. We have created 3 folders with those names that you see there. Another way of looking into this is with this command. It will show you a little bit more information about the content of a folder of a directory. You see here several columns. The first column is basically the permissions. We will not enter in those details right now, but they encode who and what can be done with that file depending on your user permissions for that. Who is the owner? To which group that belongs. So if you are a researcher, you have your own group, and all your students belong to the same group. So that indicator will tell you that. And after that, the date when that file was created, and the name of the file. And there are a couple of folders that you see there, and they are special folders. So one is the double dot, and the double dot, what it does is that is like a shortcut for the folder on top of the folder that we are currently located. So when we hit this, we are returning to my home folder. This is also called the home folder. So let's go back here, project 2020, sample 1. So right now I am here. If I hit this, I go one folder up. The dot is a shortcut to the same folder where we are. So if we hit dot, just one dot, we just simply go to the same folder where we are. Okay, so we are not doing anything here. So more commands. If you want to create one file, an empty file, there is a small trick for doing that without having to edit the file or anything. It's just the command touch. Let's say, imagine that we would like to create a file here, so we can just hit this, and we have created a file, and we can see the size of that file is 0. So we have created an empty file. If you are, let's see, here, you can do exactly the same, indicating the name of the directory and the name of the file. So we can do exactly the same here for this, and exactly the same here for this. So we have created 3 empty files, one of each sample directory. Okay, so now imagine that we would like to have something like this. Let's go to sample 1. Let's do this. Okay. So, and let's redirect this to a file called current date, for example. We can see now that we have 2 files, one empty file and one file with 29 bytes, and we can see that file with cat. It contains the date. So how we copy files? We can copy files with cp. The origin and the destination. You always work this way: origin, destination. So we are copying this file, current date, into another file that we'll be creating with the name past date. We hit enter and the file has been created. In a similar way, we can move files, basically renaming files with mv. We can convert this current date into future date. Now you see that we have the past date that was a copy from the current date before, and we have this future date, but current date doesn't appear anymore because we have moved it, we have renamed that file. And we can copy these files, for example, into a different folder. So we indicate the origin, the name of the file, and I am now using the double dots to indicate one folder add, and now go into the directory sample2 and copy that file there. And now do exactly the same here. So this is a way of copying files with the command cp. It only copies one or several files into a folder. So you can do something like this: past date, future date, copy this to the directory on top of where we are currently located. So we can copy several files. What you cannot do is to copy those files into a third file. This will not work. Past date. It will fail because it's thinking that you want to copy this into a folder called bad date, and that this folder doesn't exist. It will not copy 2 files into the same file, into a third file or something, and that will not work. So another command, so we go cp mv, deleting files. Let's go here, for example. We have this a couple of files that we have created. We copy from the sample 1, and we would like to delete those files. So I can execute this rm future date, and I can delete the file. And I can do the same with past date. So we can delete one or several files. What happens if we try to delete sample 1? It fail. You cannot delete, just like this, entire folders, even if the folder is empty. So what we can do is, for example, remove future date here, past date here, and execute a different command for removing empty folders. It's not empty. Okay, it fails if it is not empty. Let me see what we have in sample 1. Oh, data. Even if the file is empty, it's a file, so we cannot delete that. Okay, no. rm sample 1 data, and now we can delete an empty folder. Another way of doing exactly the same with a folder that contains something is using the command rm with arguments. Basically any command in Unix, Linux can be modified, its operation, by adding arguments to the command. So usually arguments start or with dash something. So for example, if we would like to delete sample 2 without having to delete every single file inside that folder, so we just want to delete the entire folder and all its contents, all subfolders and subfolders inside those subfolders, it will go recursively. So the R stands for that, for the recursion of the deletion, and force is, and the F means force that deletion for all the files beyond that. This is a very powerful command, and be very careful with that. So it will delete all the folders and subfolders beyond that. And we can try to do this. We don't need the F for this particular case. So now rm is another command. So I think we have our first collection of 10 commands that you should learn, at least those 10. Those are the most important commands, and they give you at least the ability to create files, to create folders, to start giving a structure. You will be learning more commands as you start getting a need of them, but with just those 10 is a very good starting point. So let's stop at this point. Thank you very much, and see you on our next episode. Bye.